Hello, welcome to the webinar, Industrial Water Challenges, New Technologies to Watch. My name is Ian Reinhardt. I'm an Associate Research Director here at Lux Research, and I will moderate today's session. Presenting today is my colleague Abhira Basu, a Senior Analyst at Lux. And I'm very excited for this talk on an important topic, industrial water use, that's really coming into focus as a sustainability and business challenge. Throughout the webinar today, you can type any questions you have in the question box on your screen. Time permitting, we will answer all the questions that we can. But if your question doesn't get answered, please do not hesitate to email it to questions@luxresearchinc.com, and we will respond. Now, let's jump into the presentation.
Great, thank you, Ian, and welcome everybody. As Ian mentioned, I'm Abhira Basu. I'm a senior analyst here at Lux Research. I've been with Lux over 10 years, and I've looked at water across that 10-year period. And what we've been doing is trying to really help our clients across the industrial space really understand how do we use less water and how do we improve wastewater management. You could look at wastewater recycling, reuse, even valorize waste streams. And so when we do look at water from that aspect for industrial applications, something that really pops out is that water is actually directly related to productivity. You need water to produce food, you need water to produce the energy you need, and you need water to produce the goods and services. So it's a key part of manufacturing as well. And so when we look at water as productivity for industrial companies, some challenges really pop out, right? You've seen industrial companies across the world face water-related challenges in their manufacturing. A good example is semiconductor manufacturers in Taiwan really facing water scarcity challenges and trying to keep their uptime. Similarly, in India, in Mexico, where there are industrial hubs for food and beverage production, there have been challenges around drought and water use over there. And even with chemical manufacturers in Europe, BASF is a good example that's had to deal with a lot of water-related challenges. And so rationing water becomes really a big challenge for these companies, forcing them to operate in restrictive water windows or having to pay for expensive water being trucked on site just to keep their uptime. So throughout today's talk, I do want to address the industrial water use challenge. We look at some of the emerging technology trends in water treatment, wastewater management. We look at what are the gaps in funding water innovations. How do you roll out new solutions? And then I want to tie it all back to that question about water equals productivity with some key recommendations on takeaways. So let's just go back to that question around water for food, energy, and manufacturing. I'm going to start off with the food side, right? So the water food nexus everybody's familiar with. As nations have industrialized over the last 5-7 decades, water use has dramatically increased for food production to sustain a growing population, to sustain agriculture processing, industrial capacity. And as countries become richer, as they industrialize, you see that the way they use water and the way they consume their calories changes. As you become richer, you increase your caloric intake per capita, but you're also seeing a shift in food choices, move away from vegetable-based calories or proteins to animal proteins. And that has massive water, land, and fuel impacts. And so satisfying that future food demand in a business sustaining manner requires a balancing act in resource use intensity, meeting those productivity goals. So water plays a critical role in that production of food. Let's look at the water energy nexus. Conventional power generation has always been a massive user of water. Production of oil, natural gas, coal, cooling water requirements in the US particularly requires anywhere between 40 to 45% of all fresh water use. If you just look at oil production, for every barrel of oil that gets produced, you're producing about 5 barrels of produced water or wastewater. So effectively, energy companies are managing their wastewater. They're managing how to deal with their wastewater streams. But You're probably thinking, we're in an energy transition. Our energy system is changing. We're going to get more energy from renewables, from hydrogen, from biomass. So overall, our net water usage, or we're going to be using less water in the future as we move away from fossil fuels. Well, I think it's more of a shift in demand. As we move from a fuel-intensive energy system, we're moving more towards a material-intensive and manufacturing-intensive system. And water for the new energy is going to be a big challenge. Just think about the amount of water going to be needed for hydrogen production. That could be a major obstacle to roll out green hydrogen at full scale. The amount of water needed to mine metals, minerals used for EV batteries. So let's look at that example. Annual production of EV batteries is going to grow significantly in the next 6 to 7 years. And to meet that demand of battery metals, you're going to need a lot more lithium mines, a lot more cobalt mines, a lot more nickel mines. And all of that has a water demand associated. We're not even talking about the downstream refining of these chemicals, the downstream production of those battery systems, and the recycling of battery technologies, which are all very water dependent. So when you look at mining as an example, you're seeing that companies that operate mines, copper and lithium mines, a good example, operate in really either medium to really high stress environments. And this is only going to increase as water scarcity becomes a challenge. So as you're moving to that low carbon future, producing the clean technologies that you need, you really don't want to be building that low carbon future on unsustainable water practices. So we've looked at the food water nexus, the conventional energy water nexus, and we've looked at the new water, energy, and materials and manufacturing nexus. And we're seeing a shifting in demand. But those are not the only challenges that you're facing, right? You're dealing with emerging and tightening regulations across industrial applications. A good example of that is contaminants like PFAS, which is a big challenge for chemicals, electronics manufacturers, downstream textiles producers, and polymer producers. And so you're having to deal with that waste, emerging contaminant waste challenge. We already talked about the metals issue, but you're also going to be dealing with micropollutants that could seep into groundwater. Then you have a wastewater disposal challenge. The further you are from a disposal source, your tipping and trucking fees increase significantly. Permit costs for discharging wastewaters are increasing as well. And if you're operating in regions where there are water stress issues, you're dealing with recycling and reuse mandates. The US, India, China are all implementing sector-specific recycling mandates like zero liquid discharge. So now that we've looked at these challenges around sourcing water, operating in these water stress environments, meeting the demand for future applications, and also dealing with emerging regulations, this kind of creates this whole opportunity for technology innovation in the water space. And so what I want to do next is look at those emerging technology trends. So at Lux, we group innovations in industrial water management broadly across 6 categories. Membrane technologies, electrochemical separation, chemical and chemical-free oxidation processes, adsorption technologies, biological wastewater treatment, and thermal innovations. And what you can see in this market map is that across these technology areas, there's a pretty healthy mix of corporates, some more established small to medium enterprises, and a lot of early stage startup activity as well. Let's take a deeper look into what innovation across these 6 categories look like. So patents are a good indicator of innovation activity. And right off the bat, you can see the patent trend, and you're probably seeing that patent activity has kind of peaked around the late 2010s, around 2018, 19. So does that mean that there is a slowdown in innovation activity in water? Not really. The R&D activity from the last 3 to 8 years is actually now maturing into commercially relevant technologies. The downward trend of more recent years is not an indicator of diminishing interest. Rather, what we're seeing is that the companies, the startups that invested and built out some of these innovations in the early half of the decade are actually harvesting the fruit of labor of these new solutions. And this aspect around innovation in water gets reinforced when we kind of overlay research paper publications. Over the same period that patent activity peaked and then started to decline, we're seeing innovation across academic research papers increase during that period. So now that we've looked at some of the innovation trends, let's look at the technology trends that's driving innovation in water. And I want to cover a couple of examples across these key technology areas. And let's start with membrane technologies. This is a pretty interesting area. I really like covering it. And what we've seen over the last decade or so is there's a move away from processing your water and wastewater through these energy guzzling thermal technologies like evaporator crystallizers, and moving part of that load towards using membrane technologies or electrifying your separation. So there's an upswing in activity around electrified separations. It helps you sustainably treat your water and wastewater. And a good example of that is brine concentration zero liquid discharge. Over the last few years, we've seen a lot of innovations come out in membrane systems and membrane production technologies. And now membrane brine concentrators are doing quite a bit of the heavy lifting for that brine concentration and zero liquid discharge step. A good example of that is MemSift. MemSift is a Singaporean company that's developing a membrane distillation technology, and it targets the semiconductor manufacturing and microelectronics industry, which has a very unique wastewater. There's chemicals in there, there's metals from the etching and plating process. And what MemSift focuses on is installing its zero liquid discharge system that lowers the energy cost required to concentrate that wastewater. When they're concentrating that wastewater, they're also lowering the disposal volume. So that's lowering trucking and tipping fees. And what I found interesting having spoken to them is that they're also looking at ways to valorize their waste stream. So they're doing resource recovery. They're focusing on nickel sulfate recovery from industrial wastewater. And what that does is it gives their partner, LinkSense, which is a microelectronics producer, a saleable byproduct from their waste stream. And that byproduct has a much lower footprint than, say, mined nickel that's converted into nickel sulfate. Anybody who's followed membrane distillation knows that it's been very challenging getting that technology to commercialize. But what we're seeing is that membrane technologies have improved in robustness, system performance and energy performance has improved. And MemSift is really an example of that revival of membrane distillation becoming a contender for small to medium scale zero liquid discharge. The other area where we see a lot of activities around biological wastewater treatment. So traditional biological wastewater treatment from the activated sludge process is a century-old technology. It does really well at economies of scale, but it has some sustainability challenges. It requires a lot of energy to aerate the wastewater, keep the microbes happy so they eat through the organics and solids. It generates a lot of sludge, and it requires a massive footprint, as you can see on the left-hand side. So for an industrial setting where footprint is at a premium, you need something that's scaled down and a decentralized approach. And that's where we're seeing innovations across bioreactor technologies like membrane bioreactors, membrane aerated bioreactors, or even microbial solutions that can really lower the footprint, lower the energy costs, and treat the water closer to the source so you can reuse that wastewater as well. A good example of that is Aquacycle. Another company developing a very underappreciated solution, microbial fuel cells. I've been following microbial fuel cells for over a decade now, and the technology has had challenges in scaling up. But what Aquacycle is doing is it's targeting a very challenging waste stream in hard to treat organics coming off food and beverage, distilleries, confectionaries, textiles, and even oil terminals where hydrocarbons are a big challenge to treat. And they only treat a small portion of that waste stream, which is the really hard to treat organics. About 3% of all manufacturing waste streams is what they treat, which is responsible for majority of the treatment costs, majority of the sewer discharge fee. And so Aquacycle puts its microbial fuel cell on site, sources microbial communities from local wastewater or ditches, and kind of feeds it to the bioreactor. It's a microbial fuel cell, so it's a self-powered system. And effectively, the value proposition that Aquacycle brings in is that it lowers the discharge permit. It helps clients, companies achieve that discharge permit compliance, reduces the cost of treatment, the cost of hauling away waste, and lowers the energy of treatment. The other example I do want to talk about is what we're seeing happening in the contaminants of emerging concern. And PFAS is top of mind. Growing impact of PFAS regulations is affecting multiple industries. There have been multi-billion-dollar lawsuits and settlements from major chemical manufacturers. Downstream brands and consumers are beginning to really move away from PFAS. But there's a legacy issue with PFAS in wastewater. And what we've seen is that traditional PFAS treatment or concentration solutions like activated carbon, ion exchange, and even membrane technologies only address some of the legacy PFAS, not the next generation PFAS chemicals. And so we see innovations around novel adsorbents and ion exchange processes. And there's a shift in focus from not just concentrating the PFAS and disposing it, but moving to destroy the PFAS. You really want to get PFAS out of destroy the PFAS so it doesn't re-enter the environment. And so we see innovations in things like supercritical water oxidation, or a company like Aquaa, which is developing something called hydrothermal alkaline treatment. The company spun out its technology from academic research at the Colorado School of Mines. And what it does, it uses heat, pressure, and chemicals like caustic soda as a catalyst to really break the carbon-fluorine bond, one of the most challenging and difficult bonds to break in chemistry. And it does it at lower pressures and temperatures than other technologies, particularly incineration, which can be really expensive to operate and dispose, and also emits toxic gases. So what Aquaa is doing is really producing an on-site PFAS destruction solution for industrial operators. So now that we've looked through the technology trends, I've spoken about some interesting examples on industrial wastewater treatment and technologies. You're probably wondering, what is the gap here in really rolling out some of these novel solutions? I think that brings me to the funding water innovation aspect of my talk today. And if you see funding in water, water has always been a sustainability challenge. It's always been, historically been underfunded and undervalued. In comparison to, say, climate tech funding, water represented less than 1% in 2023. But that's changing. Even at that 1%, water was funded the most that it's ever had been in the last decade. And so you're seeing this rising trend in investment activity, a lot of it driven by venture capital. And you're probably wondering that there's a spike in activity here in innovation, in funding water technologies, particularly from VC-focused companies, even at a time when there are headwinds that VC companies are facing and really not investing that much in climate tech. And you're wondering what that reason is. And let me go back to the challenges that I described. I think water stress, regulatory requirements, and really having availability of water is what is driving companies to look at investing water and address water as a sustainability challenge. The other thing that I want to point out is, like, within the same timeline that investment activities increased, patenting activity peaked, right? So there's a lot more confidence in the in technologies that are now getting commercially rolled out. And a great example of that is Gradient. Gradient was the first unicorn in the water space. It raised about $225 million in its Series D. And Gradient spun out its technology from MIT. It developed a carrier gas technology directly targeting oil and gas wastewaters. But they've expanded their approach. They're now developing a suite of solutions, which includes things like advanced membranes, oxidation-based processes, smart chemical dosing, really targeted at the manufacturing sector. They've also used the funding of companies. They've acquired a company called Synota, which is doing machine learning algorithms to really improve that membrane operations, the reuse facility, lowering operational costs for its customers. The company's expanded into Europe. It's now targeting applications like semiconductors, pharmaceuticals, mining, again, key manufacturing areas that I highlighted earlier, which will really have a growing demand for water and water solutions. And Gradient's not the only one. We're seeing greater frequency of big money rounds that's coming on. And that really indicates that the sector is maturing. You've got Cambrian Innovation doing a membrane bioreactor solution. They raised 200 million. You've got membrane technology providers like NX Filtration, Zwitterco. Adionics is directly using a solvent-based system for mining challenges in South America. So you're seeing there's a growing momentum around new innovations in water and trying to fund those technologies. So now that we've talked about the technology challenges, the gaps in funding and how those gaps are being addressed, I really want to come back to the initial topic, that the initial point that I made. Water is a productivity challenge for food, energy, manufacturing, and associated industries. But I really want to take it one step further. If you want to build that climate-proof food system, if you want to be able to successfully implement the energy transition, and you need the materials and materials and technologies that will support that energy transition in a sustainable manner, you're really going to have to think not just water from a productivity standpoint. You're going to have to think of about water recycling that directly impacts your productivity. If you have access to water through recycling of wastewater, you're really going to be lowering your vulnerability to production. And we're already seeing that momentum in water technologies shift towards recycling and reuse of wastewater. A decade ago, if you asked people what technologies you should fund for the future that will solve water problems, everybody invested in desalination. And good, they did, because a lot of those technologies are now being used on the industrial wastewater reuse and recycling. And you can see that over the last decade, new desalination capex has been dwarfed by reuse capex. And a good example, a cheeky example of that is brewing companies, microbrewers, and even some larger established food and beverage companies are really considering recycling their wastewater and producing beverages. Now, a lot of my Dutch colleagues might not like that, who are pretty big connoisseurs of beer, but this is a good example of how you can lower your vulnerability from sourcing water, but at the same time produce a more sustainable product. So again, coming back to, if you're building that system, climate-proof system, the energy transition, and looking at sustainable manufacturing, you really need to be looking at innovations across water recycling. And I've touched upon a lot of these innovations that we've covered. We've spoken to most of these companies and really tracked the innovation in water reuse and recycling. So I do want to conclude with a few recommendations here. I think water is becoming more of a climate change challenge for industries. We can't ignore that anymore. It's an operational and supply chain risk. There are already solutions that help in an industrial setting lower that water risk. You're seeing growing momentum around new solutions. We've covered a bunch of new technologies that are reaching commercialization. And now we're seeing investment activity also catch up. A lot of investors are getting a lot more bullish about the prospects of water technologies. We're seeing purely water-focused VCs pop up that are funding new technologies. And lastly, if you're thinking about water use in your industrial setting, you really need to be thinking about water reuse and recycling. That solves two big challenges. It helps you reduce your water consumption, and it also helps you manage wastewater and find ways to kind of valorize your waste stream. So with that, thank you. And yeah, happy to take some questions.
Fantastic. Thank you, Abarab. We will now be taking questions from the audience on the presentation. You can type those into the question box. I already see a few rolling in. And if we don't get to your question on the call, someone from Lux will be in touch after the webinar. So I see a few mentioned the keyword PFAS, this chemical of concern. This one that interests me, between the two main modes of treatment, disposal or treating it, which of those two approaches do you think will be most successful in the future?
Yeah, I think it's going to be a combination. There's a lot of technologies already addressing the treatment and concentration of PFAS. A lot of chemical companies have invested in those kind of solutions. Think of activated carbon being a really solid adsorbent for PFAS or newer versions of that. I think the innovation momentum is going to shift. It's going to go towards destruction of PFAS. There's a lot of early stage activity. We covered a company called Aquaa that's doing destruction of PFAS, but there's other technologies over there, things like advanced oxidation, plasma, really early stage stuff. But I think destruction of PFAS is where there's going to be a lot more focus in the future.
Great. So question number 2, how can these water technologies reduce CO2 emissions in industry? So which technologies will have a big impact on the carbon footprint of production?
Yeah, there are a lot of companies that are looking at reducing the carbon intensity of wastewater treatment. I think when you're in an industrial setting, when you're trying to treat your wastewater, there's a lot of focus around concentrating that waste stream. And today, or at least historically, the solutions over there have been largely thermally driven, right? So evaporation-based solutions, distillation, crystallization, really energy hogging systems produce a lot of emissions. And so over time, we've seen that things like membrane technologies, membrane distillation was one example I covered, but other innovations around high pressure RO systems, ultra high pressure RO systems, forward osmosis are really becoming the kind of go-to solution to do that brine concentration at a much lower energy penalty, and then lower, obviously, the overall footprint of the treatment process.
Got it. Okay. Pick another one out here. Someone is asking, are there obstacles to deploying these technologies as retrofit solutions? So do you think that a greenfield would be the most common approach, or will companies be able to efficiently replace their existing processes with some of these more innovative technologies?
Yeah, that's a good question. And in the water industry, I'd say the technologies that have historically succeeded are ones that can easily retrofit in wastewater operations in an industrial setting. A lot of industrial companies really don't want to deal with wastewater. They don't want to think about how to manage their waste stream. They want to find a company who comes in, does a plug and play, retrofit that their operations, lower the footprint, lower the cost of treatment. So you're going to see more success if you're able to retrofit solutions. The biological wastewater treatment ones are a good example. The traditional biological technologies like activated sludge have a really big footprint. But if you were to extend or increase the capacity of your wastewater treatment, you really want to look at things like a retrofit of a bioreactor, membrane bioreactor within the existing wastewater process that you have, without having to, increase your footprint or increase the energy that you're using for treating that wastewater. So yeah, there's a lot of these retrofitting solutions that are finding momentum these days.
Mm-hmm. Great, yeah, thank you. Very clear. So I see we're getting near the end of the time now. So even though there are a few more questions, I'd like to wrap us up, and we will get to those. So thanks again, Abarab. That concludes the webinar for today. The slide presentation and recording from this webinar will be sent to all attendees via email, so you'll see that soon. And after leaving the webinar, you'll be prompted to complete a survey on today's presentation. We would appreciate any feedback you have to help inform us and improve future webinars. So please take a moment, check out the upcoming webinars, and hope to see you there as well. Thanks so much for joining us today. Have a great day.
Thank you.